Okay, welcome everyone. Today we are doing is the ARDL model with integrating bounds approach. This model is used when the variables are mixed order of integration and 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 it's a time and there is no endogeneity. So we'll go towards estimating this model. So these are following libraries that are used. So time series requires a large set of data libraries that help to estimate the model. So I will iterate few of them. So there is dynamic nonlinear models. So if you want to add lags, this model is, library is used. Then for time series function, there is a zoo library. Then to read Excel file is read Excel. For data manipulation, it's Tidyverse. For any coefficient test, it's LM test and time series function. It's TTR also there. There is if you want to modify the variance covariance matrices, it's for robust regression. It's sandwich library. Then autocorrelation test is a car library. Time series unit 2 test is time series. The detailed unit 2 test for it's a unit root and cointegration test. SUCR, URCA and ECM model is this, and forecasting for this. Meter for presentation tables. Modeler for adding residuals in the data file. ASTSA is applied time series library data analysis. TS boxes for time series graphs. VARs for VAR model. DLAG-M for ARDL diagnostics. Mod for creating lags and first differences. And TSDYN for a Johansson approach. VAR test for variance ratio test. ARDL is for the ARDL cointegrating bounds that we are doing today, and NARDL is non-linear ARDL model. We highlight all of it and then we execute. Just these are the possible libraries that we are estimating today. Then we'll import the data file. So this is the command df read Excel and the directory of the data file. And highlight it, it will read the data file. Its data file includes the variables of agriculture, GDP, industry, rail, road, sea, services, air. So this is a template data file that we are using today. So it's from 1982 to 2016. Then we'll start and then we calculate log of a variable. So highlighted data file, select equal to data file pipe mutate log GDP, LGDP is equal to log GDP. So when I execute it, it will calculate a log and it cannot find the mutate function. So this problem is that it has not read the tidyverse library. So mutate function is there. So how to find it? Let's see. So mutate. So it will read the command and see where the mutate command is. So mutate command comes under, let's find it here, mutate, mutate. So it comes under dplyr. So dplyr. So if there's sometimes this error comes, you need to find which library it is using. So dplyr and add two columns. So columns, what will happen? It will read it by force. Why it's sometimes gives a problem? It gives a problem because either the library is not read, so we'll just add dplyr so that it is read for the next time. Secondly, if it has a clash with other libraries, so what we will do is that we by force read it. Then we calculate a square of agriculture. Is still saying it's not reading. So what we'll do is we'll read the library and then do it, and it will work. So sometimes there's a clash, and you can solve it using this approach. Or if the library is not read, then you can read the library. How I understood why there's a clash. So see, when I read the library, it is saying that this select command has a clash with mass library, which I have already loaded indirectly. And there's a car library, there's a recode clash, and stats library has a lag with clash with filter. So that's why sometimes there's a clash. And in previous video, we talked about simple OLS. So we estimated OLS from here, and then it did its diagnostics, and we found out that the residuals are cointegrated. So it means the OLS model will not work. So then we go towards this unit to test. So first of all, we discuss how many lags we should select. So we run the PACF graph, and the diagram is, so because it's in the shaded region, so the diagram is shown below. So only one lag is significant. So what I will do is I will run ADF test for lag 1. So I find out that it is insignificant. So null hypothesis variable is non-stationary. So this way the reason is found that OLS, why OLS was not working, because the variables are non-stationary. Then we also checked if the data has constant or non-constant variance. For that, I've loaded this library because this low and McKinley command has a clash with dplyr. So first of all, I removed the dplyr library and then estimated this uh, low and McKinley test. So it's DFT is not found. So I have to also declare that it's a time series data. That command is shown here. So let me move it up and move it here. So when I estimate it, it will show me the critical value 6, 7, and 10. And my model, the values are smaller than the critical values. It means the model is the model has non-constant variance. So this way it's confirmed that we will go towards the non-stationary mixed order ARDL model. Now go towards this approach. So I will go down and show the commands. So this is, so first of all, you will make a ARDL, simple ARDL model. So ARDL is equal to ARDL dependent variable and independent variables and lag order 2, 2, 2, 2, 2. So you have 1, 2, 3, 4, 5, 6 variables. So I've written 6 times. You can change the lag order, but I have just assumed that all have lag order 2. When I do the summary, so it will estimate the ARDL model. So this is simple ARDL model, not the Cointegrating bound. So you can see that the the the, the residuals median is almost 0. So residuals are fine. Most of the variables are significant. The stars are showing they are significant. So this is simple ARDL model. Means if we are unable to find any cointegration, this will be our final model. If there is cointegration, we will move ahead. So in the theory, this model is called unrestricted ARDL model. And if we are able to find cointegration, we can generate the restricted ARDL model, which is also called ECM. If the variables are all variables are I1, and if all variables are in mixed order, then if we call it ARDL bounds model. So we are able to estimate the ARDL question. So you can see the F test statistic is significant, means even if there is no cointegration, this model is significant, means we don't have to go back and revisit the model because the model is working. And you can see R square is almost 99%. And now we go towards the other commands. So now what we'll do is we'll find what is the optimal lag order. For that we use auto_ardl and say that this is the maximum lag order, and use the Bayesian information criterion. So when I execute it, and you will be able to see it will estimate, and let's see if the table is so it will show the results when you say model 1 and show me the top orders. So when I run it, so if you go below, you will be able to see. So the model suggested that out of all possible combinations, lag 1 0 0 0 0 0 is optimal model, and it has the lowest value of PIC, while there are other combinations shown here. So it has shown top 19. So but it has tested many other. So this way it has proposed us to select lag order 1 0 0 0 0. But in this tutorial, I will first of all move with one example that has a significant F test, so that we can move forward. Then we'll go back and see if lag 1000 has good results. So I will use the RDL model, same one as shown above, with lag 22222, and when I run it, so I will estimate summary RDL. We have already seen it. All variables are majority are significant. First of all, we'll do the T-bound test. And when I let it ask it to show the T bound, so the T bound value is minus 4.520. It is upper than the upper bound it is not above the upper bound value minus 4.79, means according to T test there is no possible no cointegration. Okay, but when I use the F bound, so T bound, you can also see its critical values. So the critical values here, so it's 2.52 and upper bound is minus 4.79. So it is not smaller, not bigger. So according to T bound, it's not, there is no cointegration. But if you use the F bound and let's show the F bound. So the value is 6.7162 and it is significant, means there is cointegration. So according to F-test, there is overall cointegration in the model. We are able to estimate the ARDL model. Now we go towards its cointegration equation. So cointegration test for a cointegration of the equation of ARDL is estimated like this. So cointegration equation 2, ARDL, cointegration underscore equation, ARDL model, which was estimated earlier, and case 3. Case 3 means that, let's write it up. So case 3 means that we are allowing intercept to be used in the model. So in economics, most of the case, the three model is used because we don't want to estimate a model which is originating from origin, means there is no intercept, or we don't want to estimate a model where there is a trend in it, which is model 4. So model 1, 2 is not commonly used, and then model 4, 5 are also not commonly used. So by default in economics, we use model 3, but sometimes we go towards them if theory asks us. So I've estimated the integration equation, and then this equation is stored. What I will do is, let's see if it has shown any results. No. So then I will use unrestricted ECM. So when I run this, it will show us the estimation results. So here you can see that it is the ECM model. How I guess it is a ECM. So you can see that there are lags and differences. So the lag variables will give us the long run, and the differences variables will give us the short run. And the lag of the dependent variable, which is this one, because we already know the dependent variable is the log of GDP. So this will give us the convergence coefficient. So it's minus 0.3 and it is significant. This variable should be negative and significant so that there is convergence. And these are the long run coefficients, and these are short run coefficients. These are short run. And there's intercept here because I allowed it to allowed the short because I use the model 3. This means there is intercept in the model. Then what I can do is, then I will go for the next model, that is restricted ECM. So what I will do is I will estimate this model. Now you are able to see here is that it has only shown me the short run coefficients, okay, and error correction component. So this is same as the above, but here the long run are not shown here. So we call this as two-step ECM and the above one as one step. So all the results are shown in one table, but you need some arithmetic operations to convert these coefficients to long run. But here all short runs are shown here, but we will be able to see the long run here. So what I will do is that it is comparing three different results. One is the ARDL result, then unrestricted ECM and restricted ECM. So I wanted to just see if the results are the same for all three approaches. So because they are calculated from each other, so it is saying true. So they are identical. Now I wanted to see what are the long run estimates. There are two ways, either to get it from ARDL or get it from unrestricted ECM. So both will give us same results. So what I will do is I will use this approach. And when I go here, so these are my long run estimates. So you can see other than the C variable, which is insignificant, all others are significant. And the agriculture is positive significant, agriculture square is negative significant, air variable, air transport is positive significant, road transport is positive significant. So this is the way we can estimate the, we can see the results. So if I add dollar sign here, you can also go for other details. So, but since we needed to see the whole results, so I never use the dollar sign. This table will also give us same results since I already confirmed that they are identical. Now what I will do is I will draw the plot for the, the GDP as a data graph and the co-integration graph that is plotted from, shown from the table. So what I will do is I will create a new variable, then I will make a plot. So you will be able to see here. So you can see the pattern of the variables is a little bit, the trajectory is similar, but the shapes are a little different. So you will be able to see that the model was overestimating here and underestimating here. So this way you can compare that the model is predicting the trajectory of the dependent variable. Okay, so the difference that you see in the values, it's from 12 to, so the difference is the intercept value. So this graph is not adding the intercept, that's why its y coordinates are not similar. So this way you estimate the model. Next is we need to do the stability tests. So for that, this is the command ARDL1, ARDL bound, same equation, same lag order. So when I run this, it will give me an array of diagnostic tests. So I will open it up and show it from here. So it's showing me that the serial correlation, it is insignificant at 5%. So there is no autocorrelation, and there's a LB test for autocorrelation. It is also insignificant at 5%. And then there is heteroscedasticity test. It is insignificant, means there is no heteroscedasticity. Then there is normality test. It is insignificant, means the model residuals are normal. Then there is bound test, and then F test is 3.444, and it is not higher than the F bound test. So it is showing us that while comparing it with the critical values, there is no co-integration. So we have to go back and select the appropriate lag order. So what I will do is, since the model proposed us to select the 1 0 0 0, so what I will do is I will do 1 here, 0 0 0 0 0. So I will estimate this model again and then see if it has significant results. So it has few of the variables significant. So what I will do is I will run the F bounds. So this value is bigger than the previous case. So, and let's see if it has a bigger T bounds value. So T bounds value is minus 5.12. It's bigger than this. So it means the model has improved. Now we'll go for its ECM value. Let's check it from here. So you can see the lag GDP is negative significant, means there is convergence. Let's go with the ECM test table. Okay, it will not work because the lag order is not shown there. So let me use this one to see the long run estimates. So you can see all of the variables are now significant because the p values are less than 0.05. Now we'll go towards looking at the graph. So when I plot it, so you will be able to see that it has similar pattern. Then when we do the ARDL model, now we need to make sure that our lag order is 0. So what I will do, I will select 0, insert button, where is insert? I will select insert 0. I will select insert as a 0. So 0 lags for independent variable. Let's see if it works. So a q must be a positive integer. So maximum q will be 1. So okay, let's start. Okay, p max, let's select it as a 0 and max dot p and let us see if it works. So it will not work. So this command does not provide us the diagnostics when the lag order is 0. So let's start with 1. Let's see row names. Okay, and max is equal to 1. Let's now work. Okay, it will work now. Okay, now look at its diagnostics. So all of them are insignificant, means there is no problem. And another thing that we need to say is that when you estimate this model, after that you need to see if it is stable. For that, there's the stability graph. It has shown, let's open it up here, and it will show us the stability graph. So you can, this way you can estimate the ARDL model. Hopefully you are able to understand how to estimate, how to run this equation for the ARDL equation, and you will be able to estimate your ARDL model using this process. Thank you very much for watching.